In this video, we're going to be discussing concurrent segments in triangles. The word concurrent means intersecting, so these are segments that when drawn in a triangle intersect. The first term we are going to look at is altitude. Okay, we might know this word meaning height, think about like the altitude a plane flies at, but the technical geometric definition is a segment that starts at a vertex and is perpendicular to the opposite side. So in this picture, I'm going to highlight right here, this line segment represents an altitude. Next, we have an angle bisector. That's a segment that splits an angle into two congruent parts, right? The word bisect means split in half. So here I'm highlighting our angle bisector, and we see the two little congruent angle markings there to remind us of the bisector part. Next, we have a median. A median is a segment that starts at a vertex and goes to the midpoint of the opposite side. Here in my picture, this is our median. This tells me that this is a midpoint here. It's split into two congruent parts. One way you could also think about this is in algebra, you learn mean, median, and mode, and median is the number in the middle. And median in geometry also has something to do with the middle, in this case that it connects to the midpoint of the opposite side. Lastly, two words that we already know kind of just combine together. A perpendicular bisector is a segment that forms 90-degree angles with the side of a triangle, and it splits it into two congruent parts. Okay, so here in my picture, we see that this line or line segment is forming 90-degree angles and splitting the side into two congruent parts. Now that we know the four concurrent segments in triangles that we're going to be discussing, when they are drawn, when there are multiple segments drawn in a triangle, there is a single point of concurrency or a point of intersection. And these all have very specific names depending upon what line segment we're talking about. So the altitudes of a triangle intersect at a point called the orthocenter. The angle bisectors of a triangle intersect at a point called the incenter. The medians of a triangle intersect at a point called the centroid. And that splits each median into a 2-to-1 ratio. We're going to look at some examples that relate to that. And finally, the perpendicular bisectors of a triangle intersect at a point called the circumcenter. Now, it can be pretty tricky to remember all four line segments and all 4 points of concurrency and which ones go together, right? All these points of concurrency sound very similar to one another as well. So 2 suggestions to help you remember which ones go together. One way I look at it is if the line segment starts with a vowel, so in this case, altitude starts with the vowel of A, the point of concurrency also starts with a vowel. And we can see that that's going to be true for angle, bisector, and incenter. And then it works the same way with consonants. Median and centroid both start with a consonant, and perpendicular bisector, circumcenter both start with a consonant. There's also a phrase that I've learned before to help you remember the points of concurrency. It's all of my children are bringing in peanut butter cookies. It's kind of like when you learn PEMDAS, please excuse my dear Aunt Sally, helps you remember the order of things. So all of is altitude orthocenter. Okay, so these pieces go together. I'm going to highlight which pieces correspond. Okay, my children relates to median and centroid. Are bringing in angle bisector, incenter. And finally, peanut butter cookies is perpendicular bisector and circumcenter. Okay, so just a tip on how to remember which point of concurrency goes with which line segment. All right, let's take a look at some examples here and some sample questions. Number 1, in the diagram, DB is a median. If AD is 5x minus 6, so I'm going to go ahead and label that, and CD is 2x plus 9, find the length of AC. Well, we know a median connects to the midpoint of the opposite side, so AD and CD must be equal to each other, and I'm going to write an equation showing that. And then I'm going to get my variables on one side, my numbers on the other, and I get x is 5. We want to find the length of AC though, so let's do some plugging back in. AD is going to be 5 times 5 minus 6, so that's 19. CD is also 19, and so total the length of AC is going to be 38. All right, and number 2, in the diagram, BD is an altitude. I know then we have right angles down here, so I'm going to fill those in. If angle A is 37 degrees, find the measure of angle ABD. So I'm looking for this angle up top here. Well, we know that a triangle has 180 degrees. So in triangle ABD, I actually already know 2 of the 3 angles. So if I solve for the missing angle, that makes angle ABD 53 degrees. All right, number 3, DE is a perpendicular bisector. Okay, that tells me AE and EC are congruent. It tells me I have right angles here. If A is 40 and AE is 7, it asks for the measure of angle ADE and the length of AC. Well, for ADE, I'm going to use the same idea that I used on the previous problem. I know that the triangle has 180 degrees, so that makes that 50. To find the length of AC, I know EC must also be 7. So together, AC is going to be 14. All right, number 4, DB bisects angle ABC. So each of these angles are 45. If angle C is 27, we want to find the measure of angle ADB. All right, so let's see if we can find some of the missing values here. I'm going to actually find angle BDC first, this angle over here, because I see that in that triangle, I already have 2 of the 3 angles, and I know the triangle must add up to 180, so that makes this angle 108. And then here I have supplementary angles, since they are a linear pair, so angle ADB comes out to 72 degrees. All right, for number 5, name the point of concurrency shown in each diagram. So what might be helpful first is to decide what type of line segment is actually shown. In number 5, I noticed that the angles are being bisected. So therefore, this point of concurrency is the incenter. In the next picture, I noticed that each side is being cut in half, but there's also right angles. That leads me to believe that the lines drawn are perpendicular bisectors, which means this point of concurrency is the circumcenter. In the third picture, I see that there are right angles, so I think these are all altitudes. The altitudes intersect at a point called the orthocenter. And finally, for the fourth picture, I see each side has been split in half, so each side has a midpoint. That means they are all medians, these line segments, and the medians of a triangle intersect at a point called the centroid. Now, there's some other problems we might see regarding the centroid, which we can see here in number 6. Number 6, G is the centroid of the diagram. If AB is 26, so I'm going to label as we go here. BC is 30. AC is 32. AG is 12. FG is 7. CG is 16. We have some different values to find here. First up, it asks about AD. So if AB is 26, D must be a midpoint since we have a centroid and medians here. So AD is going to be 13. If I am finding BE over on the right here, that side of 30 is going to be split in half. So BE is 15. And I'm going to do a similar method on the bottom. 32 is split in half, so FC is 16. Now, for the 3 remaining values, these are all parts of a median. If we look at what it asks for next, GE, you can see that it's just part of a median. Like the whole entire median, if I highlight here, is AE. GE is just part of it. So back on the previous page, I'm just going to scroll back for a second. We said that the centroids split each median into a 2-to-1 ratio. That means the numbers reduce to 2-to-1, or one number is always double the other, one's always half of the other, depending which way you're looking at it. So if I take a look at AG, if that's going to be 12, I know that GE is going to be 6 because 12 and 6 give me a 2-to-1 ratio. I'm going to use that same logic to find the next values. GB must then be 14 because this median here must be in a 2-to-1 ratio. And then lastly, GD is going to be 8 because these need to be in a 2-to-1 ratio. For these problems, we are going to assume that the pictures are drawn to scale to help us find the missing value and decide, oh, do we take the given value and have it, or do we double it? Hopefully this lesson and this video helps you understand concurrent segments within triangles.